Hi, welcome back. We just have a few loose ends to tie up about triple integrals. So this could be considered applications of triple integrals. The first thing to know is that if you want to calculate the volume of some region E, well, we could just set that up as a triple integral over E of 1 times dV. So just like we could calculate area as the double integral of d area, we can calculate volume as a triple integral of d volume. In general, we're not going to be calculating four-dimensional volumes, but you could think of these as four-dimensional volumes. But some regular applications of this would be, let's say you have some density function. And this could be a mass density function, this could be a charge density function, but basically if you have a function where on every little bit of your large region you have some density, you know how dense the object is at each place, where your density is in mass per unit volume. Before it was in mass per unit area, but now we're dealing with mass per unit volume. Then you can calculate the total mass of the object by integrating over this mass density function. You could also think of this as, like, we could deal with mass density function, charge density function, probability density function if you're dealing with a probability over a room. Like, how likely is it the cat is going to be in a certain area? Then you could maybe figure out, well, how likely is the cat going to be in this corner of the room or another corner of the room? The other thing you can talk about is you can talk about the average value of a function of a function of three variables. And just like before, we calculated the average value of a function of two variables, and we said it was 1 over the area times the double integral over our domain of f of xy dA. Well, this is the same idea. You take the total amount of temperature in the room, and then you divide by the size of the room, and that's going to give you the average temperature in the room. We could do that in the Earth. We could find the total amount of heat at any place on the surface of the Earth, divide by that total amount of space, and then you would get the average heat, the average temperature at any place on Earth. So those are a couple applications. You could probably imagine some more. But the same idea of taking a large thing, breaking it up into little bits, adding them all together, and then doing something with that information. All right, next time we're going to be talking about what happens if there are regions that are more like polar regions, but in higher dimensions. See you shortly. Bye.